My presentation is emotion recognition using convolutional neural network. There are 5 parts in my presentation. First is the problem under study. Second is existing approaches. There are 3 approaches introduced in this report. Third is the approach proposed in this project. The fourth is performance evaluation on the proposed approaches. And the fifth is conclusion. First, the problem under study. Facial expression recognition is a hot topic in human-computer interaction. We want to know the emotion of the users by capturing their faces. And the goal of this project is to classify 7 emotions from the face images. This figure are the images from extended CK database, and it shows 7 emotions: angry, contempt, disgust, fear, happy, sadness, and surprise. There are 3 existing approaches that have good performance on emotion recognition using convolutional neural network. And the first is real-time facial expression recognizer using deep neural network. It is proposed by Jinhua, and the figure below shows the method used in this paper. It first extracts a random patch from the original image, and it is as the input of the convolutional neural network. It then uses 3 convolutional layers, and each followed by a max pooling layer. And finally, 2 fully connected layers with a 40% dropout are used for classification. And this approach shows a test accuracy of 70% on FER 2013 database. This database is collected by 2013, and the human accuracy on this database is about 65% accuracy. So this method has a good performance on this database. Another approach is hierarchical committee of deep convolutional neural networks for robust facial expression recognition. It was proposed by Bokian Kim. It uses multiple convolutional neural networks followed by a hierarchical committee. So during the training period, it needs to use a lot of time to train. It also shows a test accuracy of around 70% on FER 2013 database. And the third is proposed by Tianyuan Chang. Its name is Facial Expression Recognition based on Complexity Perception Classification Algorithm. It divides the training set into an easy training subset and a difficult training subset. It has a test accuracy of 71% on FER 2013 database, and it has a 98% accuracy on extended CK database. Next is a convolutional neural network proposed in this project. We can see here there are 7 hidden layers in total, including 4 convolution layers, 1 max pooling layer, and 2 fully connected layers. I divide the convolutional neural network into 3 stages. The first stage contains a convolution layer and a max pooling layer. It is designed to extract features because we don't know how many features we need to extract it. So I just extract 512 features in this stage. And the second stage is 3 convolutional layers, which is used to do feature analysis. And the last stage is 2 fully connected layers with 50% dropout, and it is used to do classification. Before training the model, we need to pre-process the original data. Here is an example on extended CK database. First, we did a face detection and locate by using a higher feature-based cascade classifier. It is used to locate the face and extract it from the background. After extracting face images, it has been resized to the size of 48 by 48 image. Here is the result of training on the 3 databases. It shows on GAFFE database. Here GAFFE database is Japanese female database. It shows on this database and FER 2013 database that the loss on validation set increases, but the accuracy of validation set shows little decrease. The loss curve indicates there is an overfit on the training data, but the overfit doesn't affect the accuracy on the validation set. This may be because the overfit is on the features that is irrelevant to the classification task, so it has little effect on the validation accuracy. And here is the time consumption on each dataset. FER 2013 database is the largest database and it needs the most time. Then is the performance on each database. First is on extended CK database. It shows an accuracy of 96% on validation set and 94% on the test set. The figures below show the confusion matrix on validation set and test set. Here is the performance on GAFFE database. It shows a validation accuracy of 66 and text accuracy is 53. The poor performance of this database is maybe because the database is so small. It has only 213 images. That is the performance of FER 2013 database. It has an accuracy of 53 on validation set and 53 on test set. This performance is also poor, and it may be because of the imbalance of the database. And besides, there are also some wrong labeled samples because it has been collected on the internet. And there are also some samples that it's hard to tell which emotion is on that face, so the performance is not very good. And in this project, a convolutional neural network has been proposed and tested on 3 different databases, and it shows a good performance on extended CK database. but relative poor performance on the other two databases. During training period, different behavior on validation set is observed, which means an overfit occurring on the useless features. And this can be used for feature trimming. And it is possible to develop a self-trimming neural network by using this information. This is a presentation for my report, and